Yes, okay, so if you can introduce yourself and announce the name of the panel, and we have some online audience too. Thank you so much.
Okay, I'm Carlos Rodriguez Franco. I work with the Forest Service in research and development. And I'm going to speak about the importance of biochar for mitigating the impacts of climate change. Uh, so before I start, I would like to speak a little bit about the relationships between carbon, forest, and biochar. Um, Carbon is one of the most abundant elements in the universe. By mass is the fourth most abundant element on Earth. And also by mass is the second most abundant element in our body. Carbon's abundance, the organic compounds, and its polymers makes all the building blocks for life as we know it. There are more than 1 million compounds of carbon and hydrogen only, just to be aware of that. And when we mix one atom of carbon with two atoms of oxygen, we have carbon dioxide, which is a greenhouse gas that creates warming and increases in temperature and increase warming on Earth. Okay, perfect. So on Earth, we have pools of carbon, which are geological reservoirs in the soil, in vegetation, and in the sea and sedimentary rocks. With the flux of movements between these poles, when we burn fossil fuels, we release carbon to the atmosphere. When we have wildland fires, when we change the use of the land from forest to agriculture or urban development, or when we deforest. But also between these movements, also we have sequestration because forests do that and then they sequester carbon and it goes also into the sea through biological sequestration. So between these movements, we are releasing and sinking carbon between the sources and sinks, but our release at this moment is bigger than that we are sequestering. The next, please. Um, when we speak about the pools that we have and those that we can really manipulate, we are speaking about soil and vegetation, the amount of carbon in the permafrost and in the ocean. And the release that we do to the atmosphere, increasing its content of carbon, is through land use and industrial emissions and human activities. We are working in trying to move the slides, but I don't know why it doesn't work. So when we speak about manipulation of carbon through the carbon cycle, what I'm meaning with this is that if we avoid the land use change, we decrease the use of fossil fuels, and we promote forest management, we can also decrease the amount of carbon and also increase carbon sequestration in the different pools of carbon. And that's something that we are really working because we want to decrease the amount of carbon in the atmosphere. And for a long time, people have been aware that carbon occurs in natural and man-made releases or emissions to the atmosphere, to the ocean, and also through biomass. Through these movements, we have effects, increases in temperature, increase of rainfall, an increase of the level of oceans, and with the consequences to human life. Um, at this moment, in the discussions that are happening in Dubai about climate change, uh, there are releases of different studies, and this one that I found yesterday indicates that we are above 1.3 degrees centigrades uh, in temperature or normal temperatures since the pre-industrial times, which is this causing warming. And people different countries in the Paris agreements have agreed that for 2050 limit this increase to 1.5. I heard in the news this morning that we are already at 1.4, and the expectation is that we will have this increase in temperature to 2 degrees centigrades at the end of this century if we don't work. So how this relates to vegetation, to disturbances that climate change is causing? Well, disturbance is defined as an event that creates a new generation of trees. And this can be natural or man-made. And it can be catastrophic and not catastrophic. Catastrophic is when it covers big areas, geographical areas, or it acts like a epidemic covering big transmission in big areas. And when are man-made, can be fire or grazing, or natural like earthquakes, fires, snowstorms, hurricanes, landslides, you name it, insects and attacks of diseases, flooding. We have seen a lot of that lately. And not catastrophic, that are almost the same, but a smaller scale. How this relates with the balance of forest ecosystems? Well, when we have intense droughts and we have overstocked forest stands, there is competition for growing elements and for growing space. When that happens, these competitions weakness the ecosystem, increasing mortality. When mortality happens, we are almost promoting the apparition of insects and diseases attacks and creating the conditions for wildland fires. So that is one example. Other example is the decrease of the snow melting faster and not giving enough time for infiltration into the reservoirs, so we have less water availability. But at this moment, until November 8th, we have 25 events of disturbance that are very costly for the country with different impacts on humans and lives and housing and on the environment. So what is this relationship between drought, mortality, forest fires, and insects and diseases attacks? Well, is the environment. We are affecting our environment. When we see through our forest inventory and analysis studies that we do in Forest Service, we assess that we have in 766 million acres, around 302 billion standing trees. From this, the assessment shows that we have 7 billion trees dead on the whole United States, which is a little bit more than 2% of the total amount of trees, so which is not too much in terms of the number of trees. But when you see how it's located, we see that we have the biggest amount in the Rocky Mountain areas, followed by the Pacific Northwest, and then Southeast, and the less amount in Northeast United States. This is really important because it has implications for forest management. And speaking about forest management through photosynthesis and moving the number of trees that we have, we can really work in the carbon cycle, increasing sequestration, but also taking into account the different characteristics of the environment that affect uh, the growth of trees. Everybody knows, for example, that at sea level we have better growing conditions because you go to the sea and you see around the vegetation and you will see high amount of biodiversity, trees that grow faster, you have more rainfall, more sun, but as long as you are increasing in altitude, all these conditions are decreasing. At a higher altitudes, you have less oxygen, less quality of that oxygen. That's why it takes longer time to boil water at high temperatures, for example. So you have less quality of light. So there are drastic growing conditions, so the trees grow slow. So we have to take into account that when we do forest management. And also the time of the year. In winter, everybody knows that trees don't have leaves, at least in the northern hemisphere. and there is no photosynthesis. There is a stage of the slow activity in the tree at that moment, so nothing is happening. And they start to wake up as soon as the temperature raises. And we can see this flux through the monitoring of carbon by NOAA. I'm sorry, it went too fast. I don't know if I can go back to this slide. I just want to show in this slide that there are different ways that we assess how the carbon cycle is happening through the monitoring of forests. We assess the amount of forest land. We know the amount of carbon emissions through wildland fires, uh, the emissions from soils, the sequestration by forest products that are harvested, and other characteristics about carbon that we track in Forest Service. So in Forest Service, we do this forest inventory and analysis that allow us to know where is carbon located at county level, where we have deficits of carbon, and where we have excess at different levels, above ground, in the ground, and below ground. So this gives us an idea of how the carbon cycle works, what we have to do to manage that, and how we can do better job. What we know is that our forests in the United States sequester between 11 to 14 percent of the carbon emissions for all activities in the United States. So this is a big amount of sequestration. And also, we know how carbon behaves along. Well, there are several activities. One of them is through what is known as Coastal Blue Carbon Initiative, which promotes the establishment and management of mangroves and aquatic vegetation along the coast in order to avoid soil erosion, sedimentation of the beaches, retain emissions of fertilizers or nitrogen, for example, and avoiding dead zones on the sea. Another is using woody biomass or biomass to produce electricity, and also using carbon capture and storage technologies. Another is through afforestation, reforestation, increasing soil carbon, and also using biochar. So these are the activities that we can really manipulate. And through forest management, what we are looking is to mitigate the impacts of climate change, trying to have healthy forests that are resistant to the drought, that are resilient to the fire, and also create this heterogeneity that we need to have better resistant forests to all these impacts. Also, we are looking into restoring burn areas after fire and continue protecting the biodiversity, conserve soil, and the watershed function in order to have ecosystem services that everybody is looking from our forests. One way of doing this is through application of silvicultural techniques to create an increased spatial heterogeneity in terms of composition of a species. So when you have one insect attack in one species, the others are not happening or they are not subject to attacks. So we have still vegetation there. Increase heterogeneity in age. It's not the same to have old trees than young trees, and young trees can be more resilient to insects and attacks. Have this diversity in structures. Structures are even age, same age, or uneven age at different ages, and also the spatial distribution. And this is through manipulation of the ecosystem. Just to give you an example of what could happen when you apply this stream clear cutting, you are not taking over all the carbon in the system. You still have carbon left because all the debris that you have from the harvesting of the trees still remains there. You have the carbon below ground, and also a lot of those trees will give you some use as furniture or other wood products that can continue having that carbon sequester for longer time. But also we have emissions coming from that harvest. So we have to balance that in order to know what is the life cycle analysis that we are doing through this forest management, through transportation, what kind of emissions we are having in the processing in the mill, what kind of emissions are being produced because of the use of electricity, for example, and the transportation of the final product. So you have to really balance that in a way that you have decreasing emissions for producing these goods and services and increase carbon sequestration. So how this relates to biochar at the end of the day? Well, you have to think again about carbon. Carbon is used very different because it can be the hardest and more transparent material on earth like diamond, or it can be so flexible and dark like graphite that you can write with it. So, and in between these two extremes, we have amorphous carbon that give us different kind of products like salt, charcoal, or activated carbon, or biochar. And biochar is a result of the decomposition of the body biomass or the biomass at high temperatures in produced during limited oxygen conditions or almost absent oxygen conditions. And when the final product is obtained, it has high carbon content. As you can see in this graph, biomass is the one with 100% of carbon, and then is followed by biochar. So in, in the carbon family, we have several products that are very similar, but with different properties. For example, charcoal is not the same as biochar, although some people say they are the same. It's not true. Charcoal it also can be flammable. Biochar is not. The use one of those is for energy production or heat production. Biochar can be used in many ways, but the current use is mostly as a soil amendment. Uh, and as a soil amendment, it can also be used for restoring degraded ecosystems like abandoned minelands. Or activated carbon that is also produced as low pyrolysis, a little bit higher temperature than biochar, but also at the end is activated with oxygen. So it can be used for filtration. So in short, I just want to show in this slide that when we do forest management, we extract different kind of products that can go to the mill and from the mill to the building construction and giving us this healthy forest looking that we have at the below the right-hand side. But at the same time, we have forest residues that can be transported to the mill and be used for biochar production or can be used for nanotechnology products, or some of those products can be used in the mill for obtaining cross-laminated timber for also for building homes or other kind of buildings. Also, we can produce biochar using mobile pyrolysis technologies in the forest and use that biochar to put it back into the system in the forest if we want to do that, or we can use it in agricultural activities. So one way to, to increase carbon sequestration, I just want to show in this slide that one way is increasing the soil carbon sinks. And one of the properties of biochar is that it's highly recalcitrant and it can last for thousands of years in the system. So manipulation that we can do is to intervene in different ways in the biosphere using biomass or promoting biomass with afforestation and reforestation, in the anthroposphere using more byproducts coming from biomass, or in the soil system, pedosphere, increasing the use of carbon in the soil. But assessments like the National Academy of Science had done in the past, not too long ago, maybe 6 or 7 years ago, they are assessing this potential of reforestation, decreasing the forest conversion to other systems through promoting forest management, doing forest plantations, and decreasing the risk of fire or doing prescribed burns and using biochar in many, many gigatons of carbon. So this is one of the potentials that we have to increase carbon sequestration. But you only have to think about this. This is something that has been used for many centuries before. For example, in Brazil, in the Amazon, in the dark soils, there is high content of ash, of biochar. And this is because in the past, when we were less people and the indigenous cultures were nomads, they were out to one place, they took out the forest, burn all the residues, and then wait to the rainy season, put in the crop, stay there for 5 years with high productivity, and go to other place and come back to the original place 20 years after, when all the system has recovered all that vegetation and producing the cycle again. And this gave us big amounts of biochar into the system, which now assessment have shown that in average you can have 100 tons of carbon per hectare at 1 meter of deep of the soil in the system. With these are the most productive soils in the world. So the importance of biochar uh, in contribution to decrease emissions is around 12%, and this assessment was done by Dr. Lehman. He is the pioneers in biochar research in United States and the world. And he said that 12% of the total carbon emissions globally can be avoided if we substitute the system that I was telling you of burning and slash the forest by using biochar to do the same kind of crops, but also through using biochar from residues from forest operations. It's almost very close. If you see in the chart, 0.21 pentagrams of carbon, which is one pentagram is 1 gigaton, and 1 gigaton is 1 billion metric tons of carbon. So 0.21 pentagrams or 0.16 is very close. So when you add both of them, the potential is really high in percentage of the global emissions that we can avoid using biochar. But projections done by other scientists indicates that at the end of the century, using biochar, sequestration can amount to almost between 5 to 10 pentagrams of carbon per year, which is more than the amount of emissions that we do per year at this moment. I really don't know if we can be able to achieve this, but I'm quite sure that biochar can contribute in many ways to good well-being of humanity. And this is because biochar at this moment is mostly used for agronomy purposes in agriculture or gardening to increase water retention, increase soil productivity, uh, have decrease in use of nutrients, increase microorganisms,
Excuse
and
me,
also,
Carlos.
yes,
Um, we have about 2 minutes left,
yeah,
so
I am almost done. I'm just finishing, just closing. One more slide, and that's all. So what I want to show you in this slide is that the blue part is what we can do through carbon removal technologies with carbon capture and storage. The brown one is decreasing the use of biofuels, and the green one is to the renewable technologies, including biochar. So at the end of the day, the benefits of doing forest management is to continue having ecosystem services, having healthy forests, and having a rural economies that can prosper in the United States. I'm sorry, I speak too much.
No, it was wonderful. Thank you so much. I would like to give an opportunity to the audience in the room to ask questions. And if anybody who has joined us online has any questions, please type them in the chat or Q&A so that we can answer them.
Oksana, can you hear me?
Yes.
We have one question, but we only have time for one question, 2-3 minutes. So I will pass the microphone, okay?
Very quickly, how much energy does it take to create the biochar? By comparison, where does it come from? Where would it come from to achieve the objectives that you were outlining?
For each cubic meter of woody residues that you have, you can obtain between 15 to 25% into biochar. In terms of energy, it depends on the pyrolysis system that you are using and also where you are producing biochar. If you are producing on site, the energy that you require is less, but also you have to take into account all the harvest system that you are using to have those materials close to you and then put it into the system. This is life cycle analysis that we have been doing. And the cost and energy depends too much in the technology that you can use. And I can send you different studies that we have done for the comparison of different alternatives.
Make that available to the organizers here. We can have offers.
Yeah, okay, I will do that. I will send it to them.
Thank you, Carlos.
You're welcome.
Thank you, everyone, for joining. We are going to end the session. Thank you so much. Bye-bye.
Bye.